Hello everyone, welcome to the first Enonic developer webinar of 2021. My name is Alan, I'm engineering manager in Enonic, and I'll be hosting today's webinar. We're happy to see so many of you joining us today, since we have very exciting content to share with you. To open our webinar, we have with us our good friend Tom Arild Jakobsen, senior consultant at Item Consulting, and a very active member of our community, who will show you how he used TypeScript to build some really cool open source plugins for Enonic XP. So if you never used TypeScript before, now is a good chance to reconsider. Tom Arild, the stage is yours. Good luck.
All right, thank you. Good morning, everyone. I'm super happy to be here with you today to talk about TypeScript in XP. I created a little agenda here, and most of the time I want us to be looking at code because that's the most fun part of these talks. But first, I'm going to give you a short intro to TypeScript. If you haven't seen TypeScript code before, now you're going to get a little primer, and I'll show you some of the basic differences between TypeScript and JavaScript. And then I'll show you how to enable TypeScript in your XP project. And then the remainder of the time, we're just going to play with code, and I'm going to migrate a part that I've written in JavaScript to TypeScript and show you how that's done. So let's just jump right into the code, because that's the fun part. All right, so I have created a TypeScript file here. It's a TS ending on my file. Well, actually, firstly, let me tell you a little bit about the motivation for using this, using TypeScript. So I am very interested in quality, and I want my code to be as robust as possible. And so I've been thinking a little bit about the most common types of bugs that I experience in my daily development. And I would say number one on the list, when we're talking about serious bugs, bugs that will crash your page, then it's probably that I'm hitting stuff that is null or undefined. I'm trying to access that, and or a child of an object that is undefined, and that can crash my page. And that is sort of the most serious common bug that I experience. Just pulling a number out of there, maybe 80% of the serious bugs that I hit has something to do with this. And this is something that TypeScript can help us with a lot. My second bug type on my list is stuff that is time-lift related. When you have a bug in your time-lift, that's easy to find, because that will, you're not able to show the page if that's there. But if it has to do with the model that you're passing into your time-lift, then it's a little bit more difficult, because that can change in different ways, and you don't have complete control of that interface between your templating and your JavaScript code. Just making that interface between those two parts really, really clear, I think, is very helpful in mitigating those types of bugs. And my third thing here, common issues that I experience, is when I'm refactoring. If I have a large project, maybe I'm not remembering to update all the parts that are using some code if I'm changing the interface a little bit. And it's only when I deploy that I'm seeing these type of errors. And this is something that TypeScript is really, really good at, because by adding types to our JavaScript code, we can lock down the interfaces much more, so that your code basically doesn't compile. You're not able to build your code until you fixed all of these places. And that's really powerful, because you don't have to spend time deploying and checking things. You find the problems build time instead. So these are the three things that I pointed out as typical problems that TypeScript can help me solve. Let's add a bonus here too, and that is code completion. This is something that TypeScript also provides for us. So when you're downloading JavaScript libraries from NPM, you can often see that they've added TypeScript types for that too, just to help with code completion. And now we can also get that server side in Enonic. And that is really, really powerful. This really helps the developer to move forward faster. You don't have to consult with the documentation as much, because the types will just guide you where you're going. I'll show you that later when we get into the real Enonic code. All right, so let's look at some codes. So here are some basic types. So the first lines you see here, line 12 and line 14, this is just the same as it would be in JavaScript. But when I hover over here, you can see it says the type is number. Okay, for this one, and it's string here. So same as in JavaScript, TypeScript can infer the types of these sort of things. And this is something that your code will rely on a lot. So you don't have to add explicit types for things all the time. You can infer it, same as we're doing here. But what's happening down here on line 16, I'm trying to assign my string, which is in another, to my number that is in my first variable. And that the type checker doesn't like that, because it says type string is not assignable to type number. So what's happening here is that we don't want to be using the same variable to keep different types or to hold different types. We want to lock down the types of things so that we don't get confused on what it actually holds. In some cases, we actually might want to let something be either a string or a number, because maybe we want to just parse that string into a number later and use it in that way. But TypeScript gives us also options to set explicit types for things. So what we have now, to set a type, the syntax is I put a colon and I say the type. So in this case, the type was a number, and it can still be a number, but I can also say I want this type to be a number or a string. And now first is a union of number and string, and you can see that the type error disappears because I allow it to be either a number or a string. So later in my code, when I'm going to be using that, I actually have to do like a check. I can check, is this an instance of number? Is this an instance of string? And then I can use it, because TypeScript will force me to resolve that union into like one of the types before I use it. So that's really powerful, so that you always have to handle every case. It doesn't allow you to sort of skip cases when you're using union types. Okay, objects. To define an object, we're using something called an interface. So this is something, an interface says that's the shape of an object that we have. So I created this interface content. It's like a really pared down version of the content that we had, content type that we have in Enonic. It has an ID, it has a valid boolean, and has a data with some fields. This is like my content from my content type. And you can see up here, I have a variable, and I say this is of type content, which is my interface down here. And you can see there's a red line under is valid, and that's because, of course, that's a typo. It's not is valid. It is valid. It's the name of that field. So that yeah, it's correct. Okay, so here I want to pick out something from this content that I have and use that as a string. And so I do a content.data.body, and I want to assign this to this variable, which is a string, but I get the red underline here too. And the error says type string or undefined is not assignable to type string. So that is because the body here, it has a question mark colon, and that means that it's optional. So the question mark colon means that this data field doesn't need to have a body. It can have a body, but it doesn't need to have it. So this would be equivalent to a union type here, which is string or undefined. That would be the same. So it's an optional field because it's still red underline here. So the way TypeScript, it forces us to actually handle then this null case. And that was the first point I said on top, like the main motivation or the main source of bugs is all these null problems. So what I could do here instead, I have to check if, does this exist? Does this field actually exist? And you can see now the red line has disappeared because I actually check if the body is there. And if it is there, yeah, TypeScript knows that, yeah, they're fine. Then this is not undefined. This has to be a string. since it's not undefined, since I already checked for that here. Or usually I would write it like this. It's not undefined, just be completely explicit. All right. So the last thing I want to show you about TypeScript syntax is generics. And generics is more like, it's like a variable, but for types. So if I take this, the object, like this shape that would come from my content type, and I pull that out into a separate interface, which I call a simple article. All right. And then I can set this here. Okay, so now we are back where we are. I created another interface for this object type, and I assigned this to data. So with generics, what I can do is to sort of pass that in, like the type as a parameter. So I add a generic type parameter, which I call data, and I assign that to data. And then up here now, you can see my content interface has a red line. It's because it's missing its type parameter. And I can pass that in, whoops, up here, like this. And now we're back again. So now I created an interface for content, which can be reused for my different content types. And I have like something that sets the shape of that content separately. Yes. Okay, excellent. So this is now we're finished with the intro to TypeScript. And let's look a little bit how we can enable it in your XP project. First, let's have a little bit of a look through this project that I've created, this little demo project. So I created two content types here, one article and one comment. I created a page, just a default page, and I created two parts, which is a view of the article and a list of comments. And this looks something like this here. Here I created some content of the type article. It has 4 comments beneath it. Here's the article view, shows an image, shows a title and like a preface, and it has some body, and it's a list of the comments. I'll open it up separately too, so we can have a look at it. All right, so that was my article view part, and that's my comment list part. Okay, so we have the code here, and what I want to do is to add TypeScript to my project. So this is a project that is based on the Webpack starter, and with the Webpack starter, TypeScript is already supported. So among other things, this types.ts file is included already, and it has some declarations, which says some of the shapes that are already found inside the XP. So actually, I have TypeScript support already by just using the Webpack starter. What I don't have is the type information for TypeScript. That is missing. And okay, so the way a TypeScript, when you write a TypeScript file and you run that through the compiler, what happens is that it spits out 2 files. One file is the JavaScript file. That is the file that is being used in Enonic on your page to be your controller. And it also spits out a d.ts file, like a definition file that has the TypeScript definitions. So the JavaScript file, we already have that part of the standard libraries for Enonic. So that exists. So what we haven't had until now is the type definitions for those files. And that is the projects that we've open sourced. We've written the type information for all of those standard libraries, and we've open sourced that. So we can add that to our project to get TypeScript support for those projects. So I'm going to do that now. So on GitHub here, I have the enonic-types library, and I'm just going to use npm to install that. It's a little bit slow, but we'll give it the time it needs. All right, so let's have a look at the article view.es6. So this is JavaScript right now. This isn't TypeScript yet, right? So as a little bonus is that you can use the type information from from the TypeScript files in JavaScript too. So if you are in JavaScript and you want to stay in JavaScript, this can still be useful for you, especially for getting code completion. It will do some improved type checking compared to what you already have. So I'll show you that first. So what I'm going to do is I'm going to add a JS doc here. It says type any, that can be anything. So the syntax to use it, I need to do an import, and I'm going to import from enonic-types / portal, and its name is portal library. All right. Now, if I go here on portal lib, which is this this variable that I gave the type, and I can press Control space here, and you can see now it gives me the entire interface of the portal library with types and everything. So code completion wise, this is really useful too. You don't have to look up in the documentation. You can just find here what you need. And it can be, you know, asset URL. You get it there. So it's very powerful. But this is a little bit like, let's call it poor man's TypeScript. So you can improve on this by actually moving to TypeScript. And that's the next thing we're going to do. Well, first of all, I want to show you something another thing that's really cool, and that has to do with, you see, I'm using non-webpack require here instead of using normal like imports. And part of the reason for that is that I can actually hijack the type of non-webpack require. I haven't fixed this for normal imports yet, but that's a really powerful thing to just get that out of the box. So I'll show you how I can change the type there to make it look up the correct library for that, or the correct types for that library automatically. So what I do, I go to the non-webpack require that comes from the webpack starter, and I replace that with my own, which is comes from the enonic-types. And this actually looks up just, here's a map between the string, which is a library, and the interface that shows the shape of that library. All right. And right now, if I remove this, it should be looking up. Yeah, you can see it knows now. It knows that it's the portal library already, but it doesn't know that now. Okay, let's migrate this to TypeScript. And to do that, I'm just going to change the ending of the file from ES6 to TS. And now at least we can see here I get it knows that it's the portal library. See the render function that I'm importing from TimeLive. It knows also the shape of that and how to use it, and it will type check that for me. But in my code now, suddenly it showed up a few errors that weren't there before, because TypeScript knows a lot now. It knows the shape of content that comes from get content, but it doesn't know the shape of the data. So how do we get the shape of the data? Because this is my article, right? This is the shape that is based on this XML, where I have my preface, I have my body, I have a image and a alt text for the image, right? And that's what I'm using here. So there's two ways to get that. One would be to just write out that interface. But the better way would be to actually just parse the XML and use code generation to get that interface. And that is like, this is so powerful and so nice. And this will create like a tight coupling between your content types written in XML and your TypeScript code. And also, like if you're using, let's say that you have a service that exposes some content as JSON, you know, and if it keeps the shape that it has, then you can use this generated TypeScript interfaces that I'm going to do now client side too. And the consequence of that is that when you change your XML for your content type, maybe your front end doesn't build anymore. Like it will stop you at the build step because the shape, TypeScript will say that, hey, you changed something here and you're not taking account for this suddenly being nullable, right? Okay, so code generation. There's this other project now. This is a plugin for Gradle. It's called the xp-codegen-plugin. And all I have to do is to add this line here to my build.gradle file. Up here on top. And what I also want to do is to automatically, I want to, every time when I build, I want to regenerate these TypeScript interfaces, because if I change them in XML and I try to build, then it will first update the interfaces if the XML has changed, and then it will do the rest of the build, and it can fail the build if I haven't taken into account the changes that I made to the XML. All right. So now, okay, so if I now update the Gradle build here, I'm going to get another Gradle task here in the sidebar, which allows me to generate some TypeScript interfaces. And the thing here is that it's not just the content type XMLs that are being read. It's actually every XML in the project. So it will generate interfaces for like everything that's in the form tags of these different types. So it's content types. It has pages config, the config for parts, for site, layout, macros, ID provider, mixins, everything. So if there's an XML that is the basis for a shape of some JSON in Enonic, then this would generate an interface for that you can use in your TypeScript code to get tight coupling between your XMLs and your TypeScript code. All right. Okay, so now suddenly comes in some new tasks here, and I'm going to run the generate TypeScript task. You can see that there's a few other ones here too. I'll just quickly mention them. I can also, if you are a JavaScript user, instead, you can generate JS doc instead. And you can use that like as JS doc with the shape of the content types, for instance, in your code. And this can also help you get code completion, and that's nice stuff. And we can generate TypeScript interfaces. I'm going to run that now. Okay, so it generates 4 files for me. So I get in the same folders where I have the XMLs, it will generate some files here. For instance, we have, I'm just going to do a, for instance, for article, we get an interface, which has the shape of the object that will come from Enonic. It's a preface, body, and it's 2 optional values. It is article image and image alt. And the reason that they are optional with a question mark is because that occurrences minimum is 0. And that means that a content creator can omit them. So we don't know that they are there. So we always have to check if they are there to handle those cases in our code. So this is like one of the places where I'm talking about that you're forced to deal with the null cases. And this will prevent a lot of bugs in your code. Okay, so this is the article view. And we know that when we do a get content, this is going to be an article that we're getting out here. So I'm going to write article, and I'm going to import that. And yeah, there were some changes here. We can see that the top ones are good now, but here for image URL, this is all red. And the reason for that is that we know now that article image is string or undefined, while image URL in portal lib, the ID there needs to be a string. It can't be undefined in this case. So we have to deal with a null case there. So the way I usually do this is that I just do a ternary expression to check that it's not undefined. And if it is, I just set this to be undefined. So it's like the same thing that we did in the introduction here. We actually we check that it's not undefined, and then we can use it. Otherwise, this whole thing can just be undefined. One last bug I see here is the alt text now. That is red. So why is that? Okay, let's have a look here. It's because the name of it was image alt. It wasn't alt text. So I just changed this here. And suddenly this image will have an alt text on my page. So this is like the type of bugs that I have found when I migrated to TypeScript from JavaScript. Like there were typos that suddenly showed up. Oh, here was something that wasn't actually passed along, and I never knew. And sort of these cases, they don't have to happen. Sometimes the content creators can always add an image and we will never hit this bug. But then suddenly someone doesn't, and then this bug shows up on your page and it can crash the page at some point. So we, in this case, TypeScript found 2 bugs for us that we didn't know about before. Okay, so that was the nullability problems that showed up. Another problem that is common was what I'm talking about, the interface here between my HTML and my JavaScript code when I'm rendering. So what I've started doing now is I'm explicitly telling what is the shape of the model that my time leaf is expecting. So I'm going to pass that in here as a generic. So the way I usually do this, I create an interface, which I call time leaf params. And I have in like every file I create, I will have this. And I just take the shape of the model because I know the shape here. And I'm going to say that all these fields are going to be string.
Tomorrow, I think we have just a little time left, maybe 2-3 more minutes.
Perfect. That's fine. Right. Okay. So what I do, I pass into my render function from time leaf the shape that I'm expecting in my HTML. And this is also a way for me I can easily jump between, okay, here's the shape that is sent in. Sometimes you send in like your whole, the object that you get from Enonic, you just pass that into your time leaf. And sometimes you don't use everything and it's a little bit difficult. Now I can sort of lock down the shape a little bit more. If something changes on another point, I will know that the shape isn't correct so that I can sort of either update my time leaf or I can update the code that's being passed there. You can see there's still a red line because these two fields are nullable. Okay, now you see the red line here under model disappeared and everything is nice and peachy. Okay, so, and that is actually it. Now I migrated my article view from JavaScript to TypeScript. And this is, let's say I found a few bugs and I locked down the model to time leaf just to make it more robust. And that's pretty much the job that I do in, like when I'm doing migration from JavaScript to TypeScript. It's something like this. It's not a lot of job because a lot of stuff is good already. I don't have to add types to everything. Mainly, if I write functions, you always want to add types to the parameters that comes into the function and the return type. And that's sort of the main place you actually add explicit types. Otherwise, you get a lot for free from the Enonic for the types library that we provide for all of these. And yeah, just the last thing I'll show you here. It's also when I'm doing an import. You can get code completion here. Just put into the string for non-webpack require. I can say I want the content library instead, and voila, it will. That's what I get. That's really powerful too, and really nice. Okay, let's just jump back to the agenda and just what's the readme? Ah, there it is. Okay, we had an intro to TypeScript, a quick one. We look at how to add TypeScript to our XP project by adding the enonic-types library and the xp-codegen-plugin. And then we played with the code and we migrated from JavaScript to TypeScript, one part. And that was the half hour that we have shared together. So thank you.
Great. That was great timing and great presentation. And I assume impressive amount of work you invested into this, but results are nothing short of awesome. So kudos.
Yeah, I think it has been really useful for us, like quality-wise. It has been really helpful, and I really hope that the listeners here will go and check it out, and it can be really helpful for you too.
Absolutely. This is the next thing I was about to say, that this should greatly simplify the life of developers building XP apps on a daily basis. So I hope you can share the code with everyone to help people get going.
What I've been working on now, or what I've been showing now, I have it on GitHub, and I'll put in some postcode on a different branch where everything has been migrated to TypeScript, like all of the 3 parts that are there. So you can see, you can get some more examples too if you want to go and check out that code.
Great, good stuff. Thank you, Tom Arild.
Thank you.
Okay, one from Thomas. When generating types, did you consider that any content reference might be null even for required fields, i.e. current user does not have permissions or referenced item is not published?
No, for a lot of these cases, no. They are sort of what the code generated is to a large degree the happy path too. Like it doesn't handle, like, for instance, if content is invalid. What's the other cases you said here?
Like if user doesn't have permissions, for instance.
No permissions. That's not being taken into account for these sort of things either. That's stuff you have to check for on the side. That's not part of the scope here.
Mm. But I guess technically it's possible to mark the fields in the schema as mandatory, right? So you.
Yeah. So it's mostly that. What's being done here is, it will check that occurrences field, and it will check if it's there or not, and that is more or less what it will do for you when it comes to nullability. Like for option sets, it has a really neat interface that. Okay, this is a little bit more technical, but it uses like a tagged union is called, so that you can only. You do your if check on the selected, and it will only show like the code that you're going to be able to use inside that if statement is only the valid case. So there's a few of these nice little things here that will also keep you on the straight path in your code.
Okay. Next question is from Mark. How does this package work in combination with the node and other repositories from Enonic?
It works well. It's sort of like the enonic-types library. It doesn't add any JavaScript code. It's just sort of types for what is already there. And I think we have supported all of the standard libraries from Enonic has types now for it, and I think it's pretty complete. And as new features are being rolled out from Enonic, we are also adding the types there pretty fast, so that we're keeping the types up to date. So with Node library, with all of them, we have types for them, and it's just type. You can use it if you want to, and you can if something isn't correct, of course you can file a bug, or you can also just add your own types for it. You don't have to use anything that's there. Everything is very optional.
Is it open source? Do you accept pull requests?
Yeah, we love pull requests. So please, if you both bugs and pull requests, and the bug part, that's also nice, and that has to do with, like, we're using this on a bunch of projects in our company, but there's also some other companies that are using this, and if we find a bug in a type and we fix that, we just fix that in the enonic-types library, that. Will be fixed for every library, so we sort of that same bug will be fixed everywhere, or it will be, the type checker will check for that everywhere. So as we are moving forward with this, we can go back. We've gone back to old projects and we found bugs in them as we've improved the types, because we can lock down and we can know that, okay, this is some places it's trying to keep the type as narrow as possible, not allowing anything that Enonic wouldn't allow. Just keeping that as tight as we can. It's very helpful quality-wise.
Yeah, absolutely. Okay, we have a lot of questions. The next one is from Thomas Hartman. Super cool. I like the idea of using interfaces for time-lived templates. Can you make time-lived respect these as well, or do you need to keep them in sync manually? That is, if you updated the time-lived template, do you need to manually update the interface, or can it be kept in sync?
Yeah, no, so it's that one. So you have to do this manually. It's more of a helper to know, like if you're changing that interface, you should know that you should change the time-lived template too. So it would just help you so that the object doesn't change underneath you without you noticing, sort of. I think time-lived, I think it's Java files with models it needs that it can respect and that it can understand, but that's not something that we're generating from the XMLs. So no, we don't get any tight coupling there. It's more of a helper so that something doesn't change without you noticing. Okay, great. Next one, are you using any particular plugins for that helper functionality in IntelliJ from SPAN? No, nothing special. Also, my colleagues are working in Visual Studio Code, and yeah, it's the same for them. This works there too. This is not IntelliJ specific.
Yeah. All right, and the last question: will Enonic help keep the types updates yeah, I guess it's a matter of responsibility. I guess we could, but I think this is more of a Tom Arild's child, and he likes to keep it updated, and but we're in constant dialogue, right? So we make the updates to our Webpack starter when Tom Arild asks us to. So yeah, and we'll definitely help out with this. No worries, because this is just fantastic. It should simplify our lives a lot.
Yeah, just one little comment there. We had a customer, this is maybe a year ago or more, that was thinking of moving to TypeScript, and they asked me, so how will this affect like the migration to Enonic 8 at some point? Like, will this be a problem? But the thing is that if we change the type, if we create types for Enonic 8 when that comes one day, if there's changes there, then this will actually help you a lot to migrate, because you can just fix all the type errors and it should work again. So this might actually, as long as the types are updated for Enonic 8, then this can be actually really helpful. You don't have to go through your code sort of manually to find that. The type checker will find that for you.
Yeah.
So one day that might be a real benefit from doing this this migration. We'll see.
Awesome. Okay, we gotta move on. So thank you. There are lots of thank yous here in the chat with Tom Arild. So as you can see, this the feedback is just fantastic. So thank you again for a great presentation, and just keep on improving your plugins. We'll make sure that we'll give it enough attention, well deserved.
Thank you very much.